Alright, hello everyone. So basically today I'm going to be looking at some grade 11 inequalities. Okay, grade 11 inequalities. Alright, it's been a minute. I think we need to get into this topic and actually see how we can go about it. Okay. Alright, so guys, if you look carefully here, we have x squared minus x minus 6, which is less than 0. What are we required to do? We want the solutions of x that satisfy the inequality that we have here. Alright, we want those values of x. If we were to substitute those values of x in the place of x, those values should give us a value that will be less than 0. Right? So what we do when we want to actually do that is we are going to write down the inequality, right? This is the quadratic inequality in standard form. So we call this standard form. This is in the form ax squared plus bx less than 0. So we have the inequality in standard form. That's what we do first and foremost. We write the inequality in standard form. Okay, that is achieved. Step number 2, we factorize. Surely at this stage, guys, we should be in the position of factorizing x squared minus x minus 6. To factorize x squared minus x minus 6, we open the two brackets simply because we can see that we can and we do have factors of 6, which when multiplied give us negative 6. When we add them, give us negative 1. Okay. Factors of 6, the numbers that go into 6. We have 6 and 1. All right. We also have 3 and 2. So these are factors of 6. 6 and 1, 3 and 2. But remember, when the sign is negative, that means that we are going to have different signs. Okay, when the sign is negative for the constant term or the last term, it means we are going to have different signs. But we know that this negative sign here tells us that the sign of the biggest factor, so the biggest factor is going to have the negative sign. So in 6 and 1, the biggest factor is negative 6. For 3 and 2, the biggest factor is negative 3. So we know that the others are going to be positive. So which factors will work? Is it negative 6 and positive 1? Or is it negative 3 and positive 2? So we can see, guys, that it is negative 3 and positive 2. Because the multiplication of negative 3 and positive 2 does give us negative 6. The addition of negative 3 and positive 2 gives us negative 1. So I am sure about my factors, and no one can tell me anything else about it. To get x squared, we write x and x because x times x gives us back the x squared. So we have factorized the quadratic expression. Number 3, we write down the critical values. We write down the critical values. What are critical values? Critical values are simply the solutions when solving an equation. Right? We refer to them as well as, we call them the x-intercepts. Alright? Or we call them the roots. So if this expression was equated to 0, that's what we mean. The solutions that we get when the equation is equated to 0. So we are going to write here critical values. We are going to write CV to denote that what we are now doing is we are writing down the critical values. Okay? So when you write down the critical values, you are imagining that this equation or this expression is equated to 0. Okay? So when x minus 3 is equated to 0 and x plus 2 is equated to 0, the critical values are x is equal to, take the negative 3 over, you get x is equal to 3, or x is equal to negative 2. These are the critical values. That's why we write CV, because at this stage we are simply wanting to identify the critical values of this expression. What did I say are critical values? They are simply your x-intercepts or your roots of the expression if it was equated to 0. The solutions when solving an equation are your critical values, x-intercepts, or your roots. So after factorizing, we write down the critical values. Step number 4, graphical representation of the critical values. Graphical representation of the critical values. So our critical values are x is equal to 3 and x is equal to negative 2. So what we do, guys, is we draw a x-intercept number line. We then draw a parabola sketch, which is a sketch that when we have a x squared expression, the function that we would draw is a parabola, because one, the x coefficient, the coefficient of x squared is a positive 1. So that means we have a parabola that is concave up, or that is smiling if you want to use layman's terms. Then the x-intercepts or the roots or the critical values of this parabola, which is represented by this expression, is your smallest x value is negative 2. Your biggest x value is positive 3. This is the x in x number line, negative 2 and positive 3. So your critical values are written as x-intercepts on your parabola. Then you need to now interpret your inequality. Interpret your inequality. When you say less than 0, the interpretation of less than 0 means when something is less than 0, means it is negative. All right. Also, this is referring to y. Okay, this is referring to the y axis specifically. Thank you so much, Mary. Thank you so much, Marianne. I really appreciate that compliment. I appreciate it a lot. Thank you, Marianne. So, graphical representation, okay, of the critical values. So, on your parabola that is concave up, you write your lowest critical value, which is -2, your biggest critical value, which is +3. And I said we now need to, after drawing the graphical representation where we can see the critical values, we then have to interpret what less than 0 means. Less than 0, guys, means negative. What is negative, guys? We are talking about the y-axis. Where in the y-axis are the values of y negative? I repeat, less than 0 means it is negative. What is negative? We are talking about the y-axis and specifically the y values on the y-axis. Where on the y-axis are the y values negative? The y values on the y-axis are negative below the x-axis. I'm going to say this again. I am saying after drawing your graph, which is a parabola, which is concave up, smiley face, where you are representing your critical values, x is equal to 3 or x is equal to -2. Your smallest critical value first, your biggest critical value next. What are critical values? Your x-intercepts or your roots. That's what your critical values are. They are your x-intercepts or your roots. So your smallest critical value, biggest critical value. When you have that represented on your graph, you now need to interpret what less than 0 as per your inequality, what this means. Guys, less than 0 means something is negative. What specifically are we saying is less than 0 or negative? We are speaking about the output, which directly refers to the y values. On the y-axis, we are referring to the y values. Where? On the y-axis. So if you have a y-axis and the x-axis, my question is, where are the y values on the y-axis? Where are they negative? Guys, I'm sure when you have your Cartesian plane, you know that on your y-axis, your y values are positive. They are positive above the x-axis. This is your x-axis. So your y values are always positive above the x-axis. You will have 1, 2, 3, 4, 5 above the y-axis for your y values. But your y values are negative below the x-axis. So above the x-axis, our y values are positive. This is where your greater than 0, meaning positive y values, belong, above the x-axis. But below the x-axis, this is where your y values less than 0 belong. It's always below the x-axis. Less than 0 means below the x-axis, because that's where y is negative. greater than 0 means above the x-axis, because that's where your y values are positive. So if we go back now and interpret directly what less than 0 means for this particular graph, we said less than 0 means where y is negative. Where is y negative? Y is negative below the x-axis. So on our graph, where is below the x-axis? Below the x-axis, guys, is situated right here. Okay. So less than 0, I repeat, means where y is negative. Less than 0, guys, this is the output. Output means y, where y is. Where is y? Negative, because less than 0 means negative. So where is y? Negative. And I'm saying it is negative below the x-axis. We know that from the Cartesian plane that y is negative below the x-axis. So graphically, this shaded part represents where y is negative. Which x values then tell us where y is negative, or in other words, where y is below the x-axis. So we can see it's from -2 all the way to 3, all right? From -2 to 3. So I'm going to say it's where x is greater than -2. Guys, greater than -2 means the side of -2. So where x is greater than -2 but less than 3. Where x is greater than -2 but less than 3. That is where what? The function is below the x-axis. This is your final answer. So we are saying, in other words, the x values between -2 and 3 are the values, if we substitute in the place of x, will lead to an answer on the left that is less than 0. Substitute any value between -2 and 3, you are bound to have a value on the side that is less than 0. That is what the answer means. Or if you want to write the answer in interval notation, you could say x is an element, then use open brackets, because less than or less than means that the -2 and the 3 are not included. So to show that they are not included, when we write the answer in interval notation, we use open brackets. So we are going to say from -2 to 3. In actual fact, between -2 and 3 is where this quadratic expression will showcase values that are less than 0. Okay, so that's why I usually say that this sort of conclusion of less than 0 is a typical situation of below and between. I usually say to the learners that this is a BB situation. when for a quadratic expression you have less than 0, it always says below the x-axis. But below the x-axis will be between the critical values. Below and between. Hence I call it BB. Below and between. Below the x-axis, between the critical values. That's what less than 0 interprets to. If we are talking about a quadratic expression that possesses two critical values, two different critical values, below the x-axis and between the critical values would be our answer. Okay, so guys, just one more time. What did I say? When solving a quadratic inequality, you must first write the quadratic inequality in standard form. This is already in standard form. What do we mean by standard form? ax squared plus bx plus c. And in this case, because it's less than 0, we are saying less than 0. That is step number 1. Step number 2, factorize the given expression that is quadratic on the left. When we factorize this, we got x minus 3 into x plus 2. We retain the less than 0. Step number 3, write down the critical values. What are critical values? Other language that helps us understand what critical values is. Critical values are x-intercepts, and x-intercepts are always found if you let y be equal to 0. So we are just for a moment thinking of this expression as if it is equated to 0 so that we can write down the critical values. So we take the expression x minus 3 using the 0 factor law, and we say x minus 3 is equal to 0 or x plus 2 is equal to 0. We get for our critical values x is equal to 3 and x is equal to negative 2. What are these? They are critical values. We make sure to write CV so that our teacher who is marking us knows that we are not writing the final answer. We are simply identifying the critical values of the given inequality. It's 3 and negative 2. Then the next step, we need to then show the graphical representation of the critical values using the parabola function. So we draw a concave up graph because the coefficient of x squared is positive, and in the stage where we factorized, we ensured that our x and x values inside the bracket are positive. So we can then freely draw a concave up graph because of the a value that is greater than 0. We smile most when the a value is greater than 0. The coefficient of x squared is positive. Concave up. Then we represent the critical values. Small critical value first, big critical value next, because this is the x-axis, and on the x-axis number line, we write the smallest and the biggest next. Then we interpret what less than 0 means here at the factor stage. What does less than 0 mean? Less than 0 means something is negative. What is negative? We know that this part represents the output. What is the output? The output represents or means y values. So we are saying we want to see where are our y values less than 0. In other words, where are the y values negative? We are specifically referring to the y-axis. So if you remember on the Cartesian plane, this is the y-axis. The y values on the y-axis are positive where? Above the x-axis. That's where positive greater than 0 belongs. our y values are negative where below this x-axis. That's where y is less than 0. So now we are looking at less than 0. What does it mean? Less than 0 means below the x-axis. So we go to our graph and we mark where is below the x-axis. Here, guys, that's where it's below the x-axis. This shaded pink area is below the x-axis. Which x values show us below the x-axis? It is between the critical values. Which x values show us below the x-axis? It is between the critical values. So since the symbol is less than 0, there's no equal sign, we then write our answer and we say x is greater than -2 but less than 3. That is between. X is greater than -2. This direction is greater than -2. That's where the values that are greater than -2 lie. They lie here. But it is less than 3. Less than 3 is in this direction. So that is what in between the two critical values actually means as the answer. This, guys, is the final answer, which receives 2 marks. We can choose to write the answer in inequality form, or we can write it in interval notation. The same answer can be written as x is an element of open brackets, because this is less than without a equal sign, from -2, or at least -2 not included. Open bracket means the -2 is not included. This semicolon means to 3. -2 to 3. Open brackets, because there's no equal sign. That also means the 3 is not included. That basically is the end of how we answer this question asked of us. Hope that the explanation is clear, crystal clear to those that have been listening. Let's go and do another problem. Let's change our attention and go to this one. X squared plus 2x minus 8 greater than or equal to 0. X squared plus 2x minus 8 greater than or equal to 0. Okay, let's look at this one. What do we have here? Another inequality. X squared plus 2x minus 8 greater than or equal to 0. So step number 1, what do we do as we start off this question? We must first check that, okay, this is a quadratic inequality. The coefficient of x squared is positive. So all things are good. The next step, so standard form, is achieved where a is greater than 0. Step 2, we want to factorize. Factorize. So F stands for factorization. So what do? We check first, okay, we have a -8. So that means inside our bracket, when we factorize, our signs are going to be different, because a negative constant always says to us we are going to have different signs. And then here this positive tells us the sign of the biggest number is going to be positive. The sign of the biggest number is going to be positive. The sign of the biggest number is going to be positive. So we first check then, what are the factors of 8? because the sign of the biggest number is going to be positive for the different signs we're going to have in the bracket. So we open two brackets because this is a quadratic expression that can be factorized. Different signs, positive and negative from the get-go. What are the factors of 8? Factors of 8, we have 8 and 1. We also have 4 and 2, the twin factors. The signs are going to be different according to the negative 8, but the sign of the biggest number is going to be positive. So between 8 and 1, who's going to be positive? 8, whilst 1 is going to be negative. Between 4 and 2, who's going to be positive? 4, whilst 2 is negative. Now, who is going to work best? Is it 8 and minus 1? Or is it 4 and negative 2? Which one? We know both when multiplied give us negative 8, no doubt. But we want now to find out which one will give us a positive 2. When we add, is it 8 and negative 1? Or is it 4 and negative 2? Because now I'm going to write my numbers in the appropriate place. Sn, you can skip baby steps yourself, right? Skip baby steps yourself. Yeah, the thing is, you must understand that in this platform, people are at different places. You, sir, are ahead. That's great, okay? But don't impose yourself and how ahead you are on my life, please. Okay, appreciate your comment, but it is also not appreciated because you understand not where people are and at what stages. We have different people at different stages. So let's respect that, please. All right. Thank you, Boy Dumelo. Positive 4 and negative 2. Yeah, it is baby steps that people are failing to grasp, which makes maths difficult. If people understood baby steps in maths, I'm telling you, and they understood them well, the basics, okay, so we factored correctly. 3. Critical values. Now we need to write down the critical values. When we write down the critical values, we must write CV to indicate this is not the solution. This is just the way to the solution. So what are my critical values now that I've factorized? What are my critical values now that I've factorized? Okay, thank you. X is equal to negative 4. X is equal to 2. Please, guys, write CV. 4. Graphical representation. Small critical value, big critical values. Graphical representation. Remember, critical values are x-intercepts. Okay, I explained what critical values, guys. Critical values are your x-intercepts or your roots. All right, these are the solutions that you would have got if the expression was equated to 0. That's what critical values are. This helps me to be able to, on my graph, be able to note what the x values on the x-axis are, right? So you could take this bracket, equate it to 0, take that bracket, equate it to 0, and then solve for x. Okay, you take the negative 3 over, you get x is equal to 3. You take the positive 2 over, you get x is equal to negative 2. So this is what we refer to as the critical values of the given expression. We are taking the expression as if it was equated to 0. Because you know that when you let y be equal to 0, you get what we call the x-intercepts in functions. We also refer to the x-intercepts as the roots, or another word that we use is critical values, the solutions when solving an equation that is equated to 0. So we write CV so that the person who is checking your work knows that you are writing the critical values. You must have this, guys, written. You can't write x is equal to negative 4, x is equal to 2 without stating CV prior to writing these values. Please, 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 as a matter of rule, write down CV and then write this. If you write these without the CV, then you may be implying that you are saying that this is your solution, and that is not the case. Critical values are the way to the solution, right? After identifying the critical values, this is your smallest critical value, this is your biggest critical value. Now we have to interpret. What are we going to interpret? We are going to interpret what this means. Greater than or equal to 0. What does greater than or equal to 0 mean? This part of greater than means that y is positive. Y is positive. We are referring to the y-axis, so we are saying, where is y positive? In other words, where is the function above the x-axis? Okay, that's what greater than 0 means. Then there's the or equal to 0 part. What does the equal to 0 mean? That means equal to 0 means on the x-axis. Where is the function on the x-axis? So I repeat, greater than 0 means where is y positive? In other words, where is the function above the x-axis? Where is the parabola above the x-axis? Equal to 0 means where is the parabola on the x-axis? So you are looking for these two things. So let me then show you. The function is above the x-axis in this region and in this region. So in this space, that's where the function is above the x-axis. then 2 equal to 0. Where's the function? On the x-axis. The function is on the x-axis exactly at -4 and exactly at +2. Okay, exactly on the x-axis, it is exactly on the x-axis at -4 and at +2. How then do we write the answer to what we've just identified? We can say now, for above the x-axis, x is less than -4. That's where the function is above the x-axis, where x is less than. All values on this side of the number line are values that are less than -4. That's where this function is above. Okay, you can see most. It will continue to be above where x is less than -4. But where is it on the x-axis? It is on the axis where it is equal to -4. Okay, we are done with this side. Let's go on to that side. There is our critical value 2. We will say, or where is the function again? Above the x-axis. It is above the x-axis where x is greater than 2. Where x is greater than 2. Where is the function for the equal part? On the x-axis. Where is it equal to 0? Where is it on the x-axis? It is on the axis exactly where it is equal to 2. This, guys, is our answer. Okay, this would be our answer. So this is one way of writing the answer. Okay, one way of writing the answer. Or you could write the answer in interval notation. Okay, the way you would write the answer in interval notation is the following way. In this region, okay, you can say that from -infinity to 4, -infinity to 4. -infinity is not included. Okay, -infinity is not included. 4 is included. Okay, then there are 2 notations or 2 things you could either then say for the other side. You could either say this is a symbol that means union. It's a symbol that means union. Union. We use this symbol in set notation. So this is a symbol that means union. You must have seen this symbol when you were doing probability in grade 10. So this symbol means union. It means in layman terms or. Then if you consider from 2 to infinity, you will say square bracket 2 to infinity, that is positive. And then infinity does not ever have a square bracket, it has an open bracket. Why did we use a square bracket here? Sorry, I forgot to write -4 here. Why did we use a square bracket here? It's because the 4, -4 is included. It is part of the answer. Equal sign means square bracket. Why did we use a square bracket for 2? Because 2 is included. Equal sign means square bracket. So from -infinity to -4, That is our answer for this interval. And then from 2 to infinity, that is accommodating this answer in this interval. And we write this symbol for union, or we can write the word or we can write the symbol, which basically means or, which is what the symbol we use in set notation. Okay, so guys, you can choose how to write the answer. You can write it either in inequality form or you can write it in interval notation. So that's why I say the fifth and final step is to write the actual answer. And that actual answer, guys, is worth 2 marks in normal ordinary exams. So if you fail, you stop there at the graph, you will lose 2 marks. I remember one year having a learner that was in grade 11, and he wrote, this was in 2022 actually, to be specific. This particular learner, final grade 11 exam, he got 148 out of 150 for grade 11 maths. The reason why he lost the 2 marks was because in question 1 of that paper, he omitted to write the final answer. He did standard form, he factorized, he wrote down the critical values and he put CV to indicate the critical values. He drew the graphical representation of the graph, and I was like, yo, this boy is going so well so far, because all the other questions before that he was doing so well. Then he forgot to write the actual answer. That is the representation of the values that would satisfy the inequality. And he was shocked himself. There was another learner in the class that got 150 out of 150, but he got 148, and he was so angry because when I gave him back the paper, he was like, yo, sir, I forgot this. And I was like, yeah, silly mistake. So please, guys, don't forget to write the final answer after your graphical representation. All right, and like I said, you can either write your answer in inequality form or you can write it in interval notation. It's up to you how you do it. So that's why I say that this one for me, above the x-axis, I usually call this the AA. Why AA? For greater than 0 and greater than or equal to 0, where y is positive, okay, I say it is above the x-axis. That's when obviously we have 2 different critical values. The critical values must be different, not the same. So for 2 different critical values, when you have a greater than 0 or greater than or equal to 0 situation, that means that's when y is positive. AA, that's the AA situation. What does that mean? Above the x-axis, away from the critical values. AA. Above and away from this side, above and away on that other side. Above and away. So I call it the AA situation if you have 2 different critical values. Okay. Let's look at another question, guys. Can we look at another question? Are we good? All right. So this is a AA situation. The one that we did before was a below and between situation, the BB situation. This is when you have a quadratic inequality and you have 2 different critical values. You can either have another AA situation or a BB situation. No, we'll do another one, don't worry. So this one was the BB situation because less than 0 means y is negative, so that's below the x-axis. Hence we said below and between, BB. So that's why I say this is the BB situation, right? Whereas this one, above, greater than or greater than equal to 0 means above and away. Okay, let's do another one. Let's do another one. Okay. Let's do this one. X minus 2x squared. X minus 2x squared greater than or equal to 0. So once again, we take a good look at the question. Take a very good look at the question. It's x minus 2x squared greater than or equal to 0. So our first step is we want to get the equation in standard form. Remember guys, standard form means ax squared plus bx plus c is greater than, ax squared plus bx plus c, where a is positive, and then obviously the inequality sign with 0 on the other side. So currently what you see, this equation is not in standard form. So what do? We try and get it first in that form. So negative 2x squared first, followed by plus x. Then we can see now we are there, but a is negative. We want a being positive. So what we are going to do is we are going to divide both sides by negative. We're going to do what? Divide both sides by negative. Why are we dividing both sides by negative? Because we want to get the coefficient of x squared being positive. So let's do that. That will give us 2x squared minus x. And then what happens when we divide by negative? The inequality sign changes direction. What happens to the inequality sign when you divide by negative? It changes direction. If you ever divide by a negative, guys, the inequality sign changes direction. So currently we had greater than or equal to 0, but because we divided by a negative both sides, we now will have less than or equal to 0. In that moment, when you divide by that negative, the inequality sign must change. Okay, are we together, guys? Any questions? Are we together? Are we following? Okay, if we are following, then great. All right, I had x minus 2x squared. I changed the order. Why? Because I want standard form. Okay, the step that is required of me in the beginning is to ensure that the inequality is in standard form. Currently it's not. So that's why I have negative 2x squared plus x greater than or equal to 0. Now I am going to divide by a negative. Why? Why am I dividing by a negative? Because the degree, the highest variable exponent that I have has a negative coefficient. I can't have that. So I divide by negative both sides. When I do, I divide this term by negative, becomes positive 2x squared. I divide this plus x by a negative. A positive divided by a negative will give me a negative. Then I have less than or equal to 0. Next step, after achieving standard form, step number 2 is I need to factorize. So if you look at 2x squared minus x, what can we do here? Because we can see that there's a common factor, we take that out. There's a highest common factor. Remember, highest common factor must be identified according to the sign, the number, and the letter. Okay, so if you look at the first term, First term is positive. So that means a positive sign is the highest common factor because the first term is positive. Number between 2, there's a 1 here. Between 2 and 1, the highest common factor is 1. The letter, when you take out the highest common factor letter, you take out the variable with the lowest exponent. The common variable, remember that letter needs to be common for all the terms in your expression. So you take out the common variable with the lowest exponent. So if you look at x squared and x, which one? X squared and x, the x is common, but which one has the lowest exponent? It is going to be x. So in other words, your highest common factor is positive x. Positive 1x. So I'm going to take that out. You take out that highest common factor. Then in brackets, you leave behind what is leftovers. So you check what's left behind according to the sign, the number, and the letter. Thank you so much for Dumel. You are also the best. Positive times what gives you a positive? So the sign is going to be positive for the first term. The one that you have here that you can't see, it's like the Holy Spirit, guys. The one is there. Can't see it, but it's there. The positive one. Who is the positive one? It is God. God is the only positive one. You know? God is good all the time. How can you say God is good all the time? It's because He is the positive one. You know, we talk about goodness, being the goodness of God. You know, so the positive one, positive times what gives you a positive? It is a positive. You go to the 1 times what is 2. There's a 2 there that's left over. You go to the letter, then x times what is x? You took out 1x. There's 1 of the x that you took out. You need 2 of the x's at the end. How many x's do you need to add to this one? Remember, multiplication of same bases. X times what is x squared? When you multiply same bases, you keep the base, you add the exponent. So what are you wanting here as far as the variable? You need another x, because x times x will give you back the x squared. So the first term is done. You go to the next one. A positive times what is negative? The sign still is negative. Then x times what is x? Key 1. You close, less than or equal to 0. Factorization has been done. Okay? I know that some of you are going to be saying, enough with the baby steps, guys. It's the baby steps that people are failing to actually take. 3. Alright, 3. You are now going to write down the critical values. What did we say are critical values? Critical values are the x-intercepts, or what we refer to as the roots of the equation. Critical values are the x-intercepts or the roots. So what are we saying in other words? We are going to write down CV. Please guys, don't forget to write down CV when you are about to write the critical values. If you omit to write this down, then it means you are doing something else. So when you are about to identify the critical values, please write down the letters C for critical values, V. Alright, C for critical, V for values. Then you can go about product of 2 factors. Okay, you are taking these as if they were equated to 0 and you are wanting to get the values. Right, so what are my critical values then for this situation? If you've written CV, guys, then you can just say x is equal to 0 or 2x minus 1 is equal to 0. Okay, so your first critical value is x is equal to 0. Your second critical value, let's just quickly solve this equation. We know that x is equal to half. These are my two critical values. We are not done, guys. We've just gotten what we call the x-intercepts, or the roots of the equation, or what we now call critical values. X is equal to 0, x is equal to half. These are critical values of this inequality. After identifying them, we go on to graphical representation. We draw your x-axis. You draw your parabola, which is concave up, because we've already ensured that the coefficient of x, and that is going to ensure that we have a positive, right? We can just come here, guys, and actually look at the graphical representation of the graph. Okay, and if you look at this stage, what is the inequality symbol that we have? It is less than or equal to 0. So you are going to now have to interpret what less than or equal to 0 means. The less than part, less than 0 part, what does that mean? It means where y is negative. Where is y negative? Below your what? Your x-axis. Okay, I am looking at this stage, and I'm using this stage to interpret. Okay, because here I went the extra mile and got the a to be positive. So where the a is positive for the concave up graph, I am looking at this inequality, not at the origin. No. I'm looking at this inequality because I've drawn my concave up graph. So because I've drawn a concave up graph, it aligns with this standard form where a is positive. So I'm looking at this expression and this inequality sign. That's why when I interpret, I'm interpreting according to this stage, okay, where a is positive. So less than or equal to 0 means what? As I said, the less than part, less than 0 part, means where y is negative. Where is y negative? Below the x-axis. So if I am going to now identify below the x-axis, we are talking about this region. I've forgotten one more thing there, and that is to write down my critical values. 0 and half. 0 should be here, half should be here. The smallest to the biggest. 0 before half. Does that make sense? On the x-axis. Okay, yeah. All right, my x value 0 and half. These are my critical values, which I also call the x-intercepts, which I also call the roots. Okay. Less than 0 means y is negative. Where is that? Below the x-axis. We did mention, guys, that on the y-axis, your y is positive here, your y is negative here. So this is the below the x-axis part. Okay, that's where less than 0 is. Y is negative below the x-axis. So that's why you see me shade below the x-axis, because that's where y is negative. Secondly, what does the equal to 0 part mean? That means on the x-axis. Equal to 0 means on the x-axis. Where is on the x-axis? Here and here. Okay, on the x-axis. So now when I write down my answer, okay, remember below the x-axis, it seems like we are between the critical values. Hence, I call this the BB situation. Below and between. Okay, you can see, guys, I mean, the x values that show below the x-axis, it's between 0 and half. So how do you write that down as an inequality? You can say x is greater than 0 but less than half. That is the less than 0 part. The equal to 0 part means on the x-axis it means equal to 0 and equal to half. That is the answer. X is greater than or equal to 0, that's the side. And equal means on 0. But less than this side or equal to half, that's on half. That's your final answer for 2 marks. Or you could write the answer in interval notation. You say x is an element. This less x greater than or equal to 0 means we have to have a square bracket because 0 is included. 0 to half. The equal sign on the inequality sign means the bracket is going to be square as well this side. So that's 0 to half. You can write the answer in this way as well. It's 100% correct. So you have 2 choices. You can either write the answer like this or like that. It's acceptable either way. That is inequalities for you, and that's how you solve a quadratic inequality with these simple basic steps, right? This is the situation when you have 2 different critical values. I repeat, the critical values, as you can see, are different. So BB less than 0 can apply nicely below and between because you are talking about 2 different critical values. Here we had greater than or equal to 0. This was a situation where we said that greater than means above the x-axis, but AA above and away on this side and away on that side. And therefore that was how we wrote our answer in inequality form and in interval notation, right? So this is for 2 different critical values. Then you can say AA above and away, right? So guys, I hope that we are really flowing or understanding this together. I want to say that as well, that sometimes, let's say guys, sometimes people, you will see maybe in the memo that some of the time you may find, if you look at this standard form here, the A value here is negative. So sometimes in some memos you'll find that they will draw a graph, but it will not be concave up, it will be concave down. Do you know why? For this specific question, it is possible for them to draw a concave down graph. Do you know why? I'm going to explain why, because I need you to understand why it is that sometimes you'll see the memo, they will give you this option, but then they'll give you this option as well. It's only for this question that is possible, but for the previous one, right, it is not possible for them to give you those 2 options. For this one, you can see the standard form, even from the beginning, had an A value that is positive, and even in the factor stage, that is the case. But for this one, right, they can look at the standard form where A is negative and look at the inequality sign that you have to interpret because of that. You are not going to interpret using this if you are going to use the concave down. If you use the concave down graph, you are going to use this inequality sign to interpret your graph. So let me just show you specifically what I mean. So the A obviously was negative there, less than 0. So most you know, we are sad when A is negative. Sad face, we are crying, we are weeping. Some of you are crying and weeping because of the maths. because things are negative, they are not great, depending on your situation, where you are. So when A is less than 0, concave down, sad face, we are crying, we are weeping, we want to cry, we want to weep, we want to sleep. All right? So concave down. Then, what is the inequality sign at that stage? It is greater than or equal to 0. Remember, we are interpreting greater than or equal to 0. You still get the same critical values. The critical values would still be 0 and half. All right? Because same solution, same critical values, no difference. But greater than or equal to 0. Let's interpret what this means. Greater than, what does greater than mean? Greater than in this situation means above the x-axis. Obviously, it means that. Okay, we can never interpret greater than 0 wrongly. Greater than 0 means above the x-axis. That is where y is positive. Let's look at equal to 0. The equal to 0 part means on the x-axis. Are we together now? The equal to 0 part means on the x-axis. So let us come now to here and check where is the function above the x-axis. I'm sure you can see where it is above. It is above here. This is where it's above, right? The function is above the x-axis here, right? Where is it on the x-axis? It's on the x-axis here. So this is the part we are looking at. But what is the solution? From here to there, we see above. From here to there, we see above. So we say not, we say x is greater than 0 but less than half still. And then on the x-axis, equal. Do you see that the answer is still the same? All right. So when you see this, understand that they are using the original expression, the equation in the standard form where a was negative. So that's why you could have a graphical representation concave down and a solution which is still reflecting the same answer as what you saw above. You could still, obviously, if you chose to write the answer in interval notation, say 0 to half, and you put your square brackets, because 0 is included, the equal sign means that, half is included, the equal sign means that you use your square brackets, and that is how you go about it. So this is for you to be able to see that doesn't matter. What's important is the focus that you place on the interpretation of the expression that you are looking at. Because we decided to look at the situation here on this standard form where a is greater than 0, we look at this inequality sign and we interpret according to that, this situation. But if you decide to look at the inequality at this stage, then you need to draw a relevant function which indicates the a being less than 0, and you use this inequality as your way of interpreting so that you write the correct answer. Okay, guys, are we good? Think Boitumelo specifically, because it seems like you have been here and you are actively answering questions in the comment section, at least commenting, so that I know. Olerato, okay, we good, eh? Okay. So inequalities, guys, really. Let's go and check out another question and see if we can. Let's look at this one. Number 6, x squared minus 2x plus 4. Let's start. So one thing you guys need to understand is that for all the questions we did above, we always seemed to have two critical values. Now let's look at this question. Let's look at this question. Yes, Kadada, I will put this on the YouTube channel when I'm done with it. Hopefully I can download it soon and then I'll put it on there. I'll write today's date in the title of the video. Okay, just make sure that you are subscribed to the channel. The link of the YouTube channel is in my bio. Yeah, and you can check out other videos, guys, that I've done with live lessons. Unfortunately, the video, the camera quality, maybe not the best, because you can see most. If you are watching this live lesson, you can see how I am moving about. Yeah, and obviously then you don't even see the comment section. You just see an open page with no comments, and you watch the video literally as no, Katata, there's no subscription payment for the YouTube channel. You know, most. You just go and subscribe to the YouTube channel. No subscription payment. Do I have to pay? Guys, if the channel is not even yet monetized, it's still in its foundational stages, not gotten the views that I need yet to be at that stage. Okay, so let's look at this one. Hopefully you are solving it yourself and you are seeing what needs to be done. The link is in my bio, Siziwe. The link is in my bio. Go to the link in my bio. It's also the link to the YouTube channel name is Maths is a Game. Just like the same profile picture. How do you know that if the brackets go from negative infinity, Z? Very quickly answer your question. Okay, remember here we had a situation where we said that the greater than 0 means above the x-axis. So when we are above, all right, we are above on this side, we are above on that side. We can never be above here, obviously, because you can see the function here at this stage is below. So we are above on this side. If you look at this side, this function has an arrow to indicate it will infinitely go, like it will continue. Guys, this is a continuing function. It's infinite in that direction. So it's infinite in the negative direction. So from this side, Z, this is the negative infinity, because remember, negative, the word infinity just means numbers go on forever. Okay, so this from here, negative infinity, all the way to -4. So this, all right, numbers go on forever in the negative direction. Negative infinity is this side. Do you see? Then on that side, the arrow, the function goes on infinitely in that direction. Does that make sense? The arrow here is to indicate we are going on forever and ever and ever. That forever and ever, from left to right, what's happening? From 2 all the way to positive infinity. That's why we say from 2 to infinity. From this direction, above here, the side, it's from negative infinity to -4, because we have the negative values. All right. Yeah, so whenever you are having the function being above the x-axis for this single critical value, whether it's positive or negative, then obviously infinitely in that direction means the negative infinity side. Okay, yeah, and when we have negative infinity, we always use open brackets. We don't use closed brackets, because negative infinity, guys, is not an actual number that you arrive at. Infinity is a concept that shows you numbers go on forever, right? And this means in the negative direction. You can count forever and die. Okay, there is no end There is no end. Okay, so I don't know if Mzi is answered, but I hope you are. If you are a person that ends at critical values, it means that you have not yet understood what it means to first do what? Because I told you guys that when you have written your critical values, this is not your solution. This is simply the way to the answer. So when you get here, okay, you are simply writing the values of x which would make this bracket 0. What would be the value of x that would make this bracket 0? What number do you have to substitute here to get 0 in this bracket? It's -4. So x is equal to -4. What's the value of x you would substitute inside this bracket to get 0? +2, because 2 minus 2 is 0. So those are your critical values. But remember, what did I say are your critical values? I said your critical values are your x-intercepts. In other words, where your graph cuts the x-axis. That's what your critical values are, or we call them the roots. Okay, so we then draw a graph that is, in this situation, the a value here, the coefficient of x squared is 1 and it's +1. When a is greater than 0, guys, we know that we have a smiling face graph, concave up. You then write your smallest critical value here, your smallest number on the number line, your biggest number on the number line. These are your critical values that you are writing here and there. Okay, then you need to interpret what greater than or equal to 0 means. Greater than or equal to 0 means what? So I told you guys and I said that when you are saying something is greater than 0, you are saying that particular thing is positive. But what are we talking about that thing is positive? We are talking about y. This is your output. Output means y. So y is positive, in other words. So we are asking yourself, where is y positive? Okay. Where is y positive? Y is positive above the x-axis. If you look at the Cartesian plane, guys, y-axis, x-axis, your y values are positive from here to there. Here they are neutral, it's 0, but your y is positive. So greater than 0 or greater than or equal to 0 means above your x-axis. Okay. Y is positive above. So this is the x-axis. So this is the y-axis. Your y values are positive above the x-axis. Your y values are negative. In other words, less than 0 or less than or equal to 0 below your x-axis. Okay. So then, to interpret this, greater than 0 means y is positive. Where is y positive? Above the x-axis. Equal to 0. This part of equal to 0 means what? It means equal to 0 means on the x-axis. Which part of the equation represents the x-axis? Which part of the equation represents the x-axis? Which part of the equation represents the x-axis? Your equation was in standard form. You factorized. Your critical values represent the values of x that you write down on the x-axis. Your critical values represent the values of x that you write on your x-axis. Your small value first, your big value next on the x-axis. Those are your critical values, because critical values are x-intercepts, and you write them on the x-axis, your small and your big. So I don't know, Kadada, what you are asking specifically. I don't know what you are referring to. Your standard form, you factorize, you write down your critical values. These are your x values that exist on your x-axis, which you draw on your x-axis for your parabola. Okay. So I don't know if I'm understanding you well, or if my explanation or anything that I'm saying makes sense and it helps you understand a bit better. But you interpret this greater than 0, guys, means where y is positive. Anything that is greater than 0 is something that is positive, right? But you are specifically referring to where y is positive. Where is y positive? It is above the x-axis. So when you're saying above the x-axis, it means on this side of the parabola and on this side of the parabola. Because you can see this is where the function is above the x-axis. It's on here and there. It's not here. No. It's here and there. What are the x values that show here above the x-axis? It's where x is less than -4. Okay. Sissy, what you are asking, is there no other way without the graph? There is another way without the graph, but the thing is, if you don't understand this way, you are going to suffer, or you are going to have a problem when it comes to your graphs, your functions. People are having a problem with functions because they don't know how to relate algebra to functions. So the exposure you get in term 1 as a grade 11 learner to inequalities and the graphical representation of your quadratic expression in function form helps you to be able to make the connection when you eventually do functions. So if you are wanting another way, I guess you can learn the other way. But unfortunately, what it's going to do, it's going to shortchange the process of you being able to make the connection with functions and then you mastering functions. All right, you are going to actually delay that process. So you need to actually get yourself familiarized with, this way so that it can assist you with the functions. So setting this way aside will come back to bite you with functions, right? Okay, because the language I'm using here is that greater than 0, understanding what greater than 0 means for your Cartesian plane is important. When we say greater than 0, we are saying where y is positive. On the y-axis, guys, your y values here, 1, 2, 3, 4, 5, these are positive y values. On this x-axis, this is where y is 0. Y is 0 on the x-axis. You go down below the x-axis. On the y-axis here, you have y values that are negative. These are your negative values of y. Okay, so greater than 0 means y is positive. We know it's above the x-axis. Less than 0, this is where the y values are negative. All right? Okay. Sure. I can do that. It seems as if the left side of greater than or equal to 0 is y-axis. No, my leader. No, man. Oh, my son. Kadada. If you have a teacher, you need to go to your teacher and go speak to him about inequalities, because I feel like you have a misconception. All right. Yeah. And I mean that not, but guys, I almost feel that some of you now are addressing your other problems No. Some of you don't have problems with specifically the topic. You have problems that relate to your lack of understanding of concepts that should have been covered earlier. That's why you guys are asking me questions that are not really related to what we are doing now. So if you are making that conclusion, Kadada, it's the wrong conclusion. Okay, greater than 0 means where y is positive. Less than 0 means where y is negative. Okay, let me say that again. Greater than 0 means where y is positive. And where is y positive? Above the x-axis. Y is positive above the x-axis. Okay, greater than 0 means where y is positive. That's what greater than 0 means. Y is positive where? Above the x-axis, because this is the x-axis, right? Above the x-axis means where y is positive. Then when you have a situation of less than 0, what does less than 0 mean? It means less than 0 is where y is negative. Where is y negative? Below the x-axis. Okay, positive above the x-axis. Guys, this is the x-axis. The x-axis is this horizontal line. So when you are saying greater than 0, you're saying y is positive. If you are saying less than 0 for an expression, you are saying where y is negative. It's the output. Guys, the output is y. Output is y. You are talking about y. Okay, so then that's why we interpreted this greater than 0. Okay, this shaded region means this is where the function is above the x-axis. Okay, where x is less than -4, that's where the function is above the x-axis. But it is equal to 0 where it is on the x-axis, that's at -4. So we can say x is less than or equal to -4. This is the answer for above the x-axis on this side. This side, the function is above the x-axis where x is greater than 2. You see it, there it is. But it is on the x-axis where x is equal to 2. So that's why we have x is greater than or equal to 2 for this side. X is less than or equal to -4 for that side. Above, greater than, above the x-axis. But look at less than, guys. Less than 0 means below the x-axis for two critical values. So that's why we shaded this region below the x-axis. Below the x-axis, that's where y is negative. But then equal to 0 means on the x-axis. So then the answer for x, it lies between these two values. From here to there, that's where we are below. From here to there. So this is how you write the answer. X is greater than or equal to 0, but less than or equal to half. Or you can write it in inequality form, in interval notation, and say 0 to half, square bracket, because 0 and half are included. If 0 and half were not included, if there was no equal sign, I would have open brackets. So you must choose, guys. You want to go for inequality form, or you want to write your answer in interval notation, because you will get the 2 marks if you write your answer in interval notation, or you can get your 2 marks if you write it in inequality form. It's really up to you how you want to write it. Just something to note, your mouth of the inequality sign will always be open to the right. Always, guys. So you always write an x in between the small critical value this side, your big critical value on that side. No, Kadada, there isn't. No. Okay. For an equation, this side means the output. Okay. Yeah, and output means y. Okay. Yeah, output, my guy. Output. Okay. No. You see, Kadada, as I was saying to you, you are addressing other issues from earlier grades. When you were doing functions in grade 8 and 9, you guys learned about the input value and the output value. All right. And if you were listening, if you were paying attention, about the output and the input, then it's these questions, which means in earlier grades we missed the fundamental things. Maybe Katata because we were playing in grade 8 and 9. Yeah, it was fun in games. Since I don't know when I'll do functions. One thing is for sure, I will not be doing functions anytime soon. Okay. Yeah. Unless in one live you decide to send me a galaxy and then you request for me to do functions. I'll do functions for you. But don't send me a galaxy today and then want me to do functions. It's just that I have an objective today. I just want to clarify this whole idea of of inequalities, because people are missing the point there. I want to do inequalities and start a bit of nature of roots. Okay, so that day when I'm going live and you decide to send me a galaxy, I'll stop everything and I will do functions for you. I'll do functions for you. You send me a galaxy, I'll do functions for you. I mean, that would be reason enough, right? Yeah, guys, please, if you can support my live goal. I do have a live goal, guys. 1,000 roses. That would be great. X squared minus 2x plus 1 less than 0 there. No rows yet. Okay, x squared minus 2x plus 1 is less than 0. Let's look at this function. So all the questions we've done above had two different critical values. So it was easy to have this situation of, okay, greater than 0 above the x-axis. We have this answer for two critical values, so it was easy. K, K, watch out, Mike, watch out. This factorization, you see, grade 10, grade 9. You see, these are problems we are having earlier grades. Grade 10 and 9 are problematic. Okay, I saw your answer. X minus 2 into x minus 1 is equal to 0. You can comment. You commented. You are the one that commented. Okay. I think I need to change my settings as well. I think maybe there's been issues there. Serious issues there. Yeah, I think I'll have to look at my settings. It's just that I've had to block and mute a lot of people, and in the process I think I may have pushed options to basically limit people from commenting certain things, but also mathematical things. So I'm sorry about that. I'll fix that soon. I know, because it's because of my settings. I need to reorder my settings. I'm sorry about that. Okay, x squared minus 2x plus 1. Remember, first step, standard form. Is the inequality in standard form? In other words, ax squared plus bx plus c less than 0 in this situation, where a is equal to 1. In other words, a is positive. Okay, do we have that situation? Yes, we do, guys. Okay, yeah, so equation is in standard form. 2, factorize. All right, now some people here are also suggesting use the quadratic formula. Well, guys, if you use the quadratic formula, I guess you can. All right, but yeah, factorize if possible. Quadratic formula should really be your last resort, and it shouldn't be always your first resort. I mean, really, guys, why did we spend grade 9 and grade 10 learning factorization only to just use the quadratic formula as a first resort? Does that mean our factorization is not up to speed? Hey bud. Okay, anyways, x squared minus 2x plus 1. Remember, this plus for the constant term means that our signs are the same. All right, I'm just thinking of my beloved grade 10s and 9s that might just be watching because they are curious about what I'm doing. Okay, you know that plus 1 means same signs, but then same signs according to who? According to the sign of the middle term. Okay, I repeat, positive constant means that we have same signs. Same signs according to who? The sign of the middle term. So what we do is we open two brackets, we put minus minus. Why do we put minus? Because positive means same sign, Same sign according to who? The sign of the middle term. So we have a minus and a minus in our brackets. Straightforward. Now you are thinking of factors. The factors of the last term. Factors of 1. What are the factors of 1? You have 1 and 1. Okay, there's no others. Okay, so 1 and 1. Okay, surely when we multiply this, we must get positive 1. When we add negative 1 and negative 1, we should get the coefficient of the middle term. That happens. Okay, we have x less than 0, and then that is basically looking good so far. Factorized? Yes, we did. Okay, then please at this stage we write critical values. Let's say you did not use the factorization method and you decided to use the quadratic formula. Guys, if you decide to use the quadratic formula, you should immediately write CV, and then you use the quadratic formula to basically get the x-intercepts or your critical values. Why do you immediately write CV? It's because when you write CV, you are telling the person that is marking your work that writing CV, what I am doing right now is me trying to get the critical values using the quadratic formula, right? Okay. I am just saying that for those people that decide to use the quadratic formula, you must write CV, then go ahead and use the quadratic formula to solve. Okay, I hope that's clear and you are hearing me very well what I'm saying. Okay, I hope you are hearing me very well what I'm saying. Okay, critical values that we have here, we only have one critical value. Okay, what value of x when we substitute in the first bracket will lead to a 0 bracket? It's 1, but it's the same value that we substitute here which will lead to a 0 bracket. So we have one critical value. In all the situations we had been doing, or all the problems we had solved so far, we would get 2 critical values, but in this one we are not getting 2, we are getting 1 critical value. So if we are getting 1 critical value, guys, what does that then mean? It means this: when you draw your graphical representation, you are going to put 1 and then you are going to sketch your graph in the following fashion. This graph is not going to cut the x-axis at 2 places. Why? Because remember, what did we say CV is? It's your critical values, or in other words, I said your critical values are also your x-intercepts, or what else? We say our roots. So that means we only have one critical value, which is 1. Right? Does that make sense? Are we good so far? One critical value, guys. 1, just 1. Okay, sense is being made. I sure hope so. Then the next step that we check here, or we look at, now that we have one critical value and our graphical representation is of a graph where the turning point lies on the x-axis, specifically when x is equal to 1. Very important. Okay, now we are going to do graphical representation, which is what you see here. our graphical representation has already been sorted. A parabola. Okay. And now what are we saying? Where this is what? Let's interpret less than 0. What does less than 0 mean? Less than 0 means negative. Okay. Less than 0 means negative. So if less than 0 means negative, when something is negative, what do we mean? We mean where y is negative. Okay. Less than 0 means negative. In other words, this is where y is negative. Question then is, where is y negative? We know almost that it is below the x-axis. Below the x-axis. Guys, I'm sorry, I am an avid person here that is not going to look at any other method. So, Buyi, I'm sorry. Okay, you're asking me to how you would represent this question in number line. Okay. Yeah, I am not a number line person. Okay. I do not even go the number line direction, to be honest. Okay. So because guys, I'm trying to make a point, maybe I'll do another live and do number line, but for now I really just want to stick to graphical because the questions I'm doing are just quadratic expression inequalities. Okay, I'm focusing on quadratic expression inequalities, and with that I am trying to really press the idea of graphical representation using the parabola since it's a quadratic expression. Remember, a quadratic expression mimics a quadratic function, which is your parabola. So I'm trying to emphasize that. Okay, maybe in another life. All right, so if you'd be so kind, can you just allow me to kind of emphasize the point? Okay, and then maybe in an alternative life, then I'll do, the other methods. There's many methods, guys, to basically solve an inequality. It's not limited to graphical representation, but the reason why there's this emphasis, or at least for me, the focus is making sure that we understand the parabola graphical representation in light of the x-axis, and then the interpretation looking at the y value of the y value on the y-axis, is so that we can make the connection between your graphs, which are functions that are coming up in another term, so that when you do those, it is something familiar that you are looking at when we interpret those functions. Okay, so yeah, I hope we can just bear with that. So where is y negative? Y is negative below the x-axis. Now, if you are saying below the x-axis, we are going to have to come to this function and ask ourselves, do you see the function represented below the x-axis? Because guys, literally, this is where you are talking. Do you see the function anywhere below the x-axis? Is the function represented anywhere? Because less than 0 means where y is negative. Where is y negative? Below the x-axis. Is the function visible, or is the function represented anywhere below the x-axis? Okay, the answer is no. So that's why we then say x has no solution. X has no solution. So if it's not represented because of the one critical value, the function is just only situated there. Not represented there, means x has no solution. Okay, right. I want to stick with this same question where there's one critical value, and what I want to do is I just want to play around with the inequality sign and change it. So we looked at less than 0. CZ were for this situation, for this specific situation, because less than 0, what does it mean? It means where y is negative only. That means below the x-axis. So below the x-axis is in this region. Is the function represented anywhere below the x-axis? No. So that's why we say x has no solution. Function not represented below x-axis. Which is why we say x has no solution. I'm going to take the very same inequality, and all I want to do is have less than there, but I'm going to put an equal sign under the less than, and we are going to see what we need to do with this one. Let's say we had this question. Okay, so what do we do? Step number 1, we make sure the equation is in standard form. Yes, you can cut data. X has no solution. That's what you say. Simple as that. X squared minus 2x plus 1 less than or equal to 0. Standard form, it's been achieved. This inequality is in standard form. Step number 2, factorize. Let us factorize. We open 2 beautiful brackets, less than equal to 0. Plus sign means same signs. Same signs according to who? The sign of the middle term. So we have a negative and a negative. Then we put factors of 1, a 1 and 1. Let's check. Negative 1 minus 1, does it give us negative 2 when we add them? Yes, it does. Multiplying gives us positive 1, so we are good. Then we put x and x. Okay, makes sense? So now we can proceed to the next step. After factorizing, we write down the critical values. So when we write down the critical values, we write CV. All right, please, you must write down CV. Then you say x is equal, there's only one critical value, guys, and it's x is equal to 1. So nothing has changed there. Graphical representation. Graphical what? Graphical representation. So let's graphically represent here. Graphical rep. We have one critical value. A is positive 1. We write 1 as the critical value, and then we say jou. Okay, are we together? Now let's interpret what less than or equal to 0 means. Less than or equal to 0 means the following. What does it mean? Less than 0 means where y is negative. Where is it negative? Below the x-axis. Okay, that's the less than part. The equal to 0 part means what? This means where the function is on the x-axis. It means what? Where the function is on the x-axis. Let me repeat this again. Less than 0 means where y is negative. In other words, where the function is below the x-axis. Alright, so if we are looking at this function, below the x-axis means this region. Is there a place where the function is below the x-axis? Once again, no. There is no place where the function, you can see it being below the x-axis. But that's not all that we are looking at. There's the equal to 0 part. The equal to 0 part, which means what? On the x-axis. Is there a place where the function is exactly on the x-axis? What is the value of x that you see the function being exactly on the x-axis? Is there a place where the function is exactly on the x-axis? I want to see in the comment section, is there a place where the function is exactly on the x-axis? Because the equal to 0 part is that. Yes, Boitumelo. Yes, 0, there is. What is that value of x where you see the function being exactly on the x-axis? Okay, Boitumelo answered it. The answer is 1. So here, where x, we say x is equal to 1. That is the solution, guys. This is the solution. What is this referring to specifically? It is referring to where the function is on, because equal to 0, this is less than or equal to 0. The less than part means where y is negative. There's no answer there. Or where equal to 0, that means on the x-axis. Is there a place where the function is on the x-axis? Yes, where x is equal to 1. That is where the function is on the x-axis. So x is equal to 1. We accept that as an answer. Thank you so much for the rose. Really appreciate it. Who's this? So kind. First gift of the day. Thank you, that guy. If only I knew who your name was, but I guess that guy will have to do. This one is higher grade. No, it's not. Kadada. If this one to you is higher grade, the only reason why it is higher grade is because you did not get exposed to it. Because at the end of the day, guys, what is happening here? We are interpreting. What are we? We're just interpreting here. You guys are saying it's higher grade because you've never been exposed. All people say questions are higher grade if they've never been exposed. So what happens when you are not exposed to something? You say it is higher grade. No, this one is the most. No. It's because you do not give yourself, or you were not given exposure. So what I'm saying is, we are still using our interpretation skills of saying, what does less than 0 mean for the Cartesian plane? It means where y is negative. Where is y negative? Below the x-axis. Do I see a place in the function where the parabola is below the x-axis? No. Therefore, there is no answer for below the x-axis. Then I go to equal. Equal means equal to 0. What does that mean? It means on the x-axis. Do I see a place where the function is on the x-axis? Yes. Where? At 1. Therefore, my answer for equal to 0 is x is equal to 1. Because that's where the function is on the x-axis. So this is not higher grade. It's simply using the interpretation. Interpreting what less than 0 mean. That's where y is negative. Guys, please tune in to what I'm saying. I am saying to you, this part represents the output. Output means y. Y where? On the y-axis. Please listen. This part represents the output. What is output? Output means y. Y where? Y on the y-axis. So your Cartesian plane has the y-axis. This part above this axis is the positive part. This part of y. This is where greater than 0, and sometimes you say greater than or equal. But remember, greater than means positive, equal to 0 means on the x-axis. Then this bottom part is the less than 0 part. This is where y is negative. Or we can say y is less than or equal. The less than 0 part means y is negative. The equal to 0 part means on the x-axis. Guys, you are just using your interpretation skills so that you can then interpret what you see in the graph and then write the answer. I don't know. I like it. So it's not higher grade. Please take these ideas that you have in your head. Some of you block yourself from fluency in mathematics because these notions you put in your head, they block simplicity in understanding, baby steps understanding, and then mastery. Once you understand, go practice. Then you practice all the problems long enough, it will become second nature. Then the maths will flow, it will be easy. Okay? But first understand. You must first understand. The Bible most says people perish because they lack understanding. It's not anything else. You lack understanding or you misunderstand. That's where the problems happen. When you misunderstand, you make a lot of mistakes because you misunderstand. Or lack of understanding leads to nothing being done correctly. Then you cry. Okay, I'll never forget, guys. I remember a 1 year grade 11 learner in one of my classes. I got 100% from it. So I had him come up and speak to the other learners in the class, and I was like, guy, can you tell the other learners how is it that you get 100%? You know what that boy said? All he said is, say, basics. That's all he said. He was like, say, all the basics from the earlier grades, I made sure that I understand those basics so that it can influence my understanding in the current terms or year's work. So you can't run away from that perspective. Let's do another one. Guys, remember, I'm looking at the same quadratic expression. This one was less than 0. There was no solution. And there was a reason why we had no solution, because we interpreted what less than 0 means. Same question, less than or equal to 0, one critical value. This one, when we interpreted, we could see that since less than 0 is still there, that's where y is negative. That means below the x-axis. For less than 0, there's no solution. Equal to 0 means on the x-axis. That means on the x-axis exactly there. That what is the solution? The x is equal to that 1. That's why we say x is equal to 1 is the solution. I want to change the inequality now and do something else here. Okay, let's just actually do this one and then say greater than 0. Let's have a greater than 0 situation. Okay, so x squared minus 4x plus 4. Okay, so step number 1, equation must be in standard form. Is the equation that's quadratic in standard form? Yes. Step number 2, write down the factors. In other words, factorize. So can we factorize this, guys? Very nicely, just beautifully. Factorize it for me. Factorize step by step. Factorize. We know. Let's see if your factorization is up to par. You factorize x squared minus 4x plus 4. Let's factorize, guys. Nice factorization question. This one, just factorize nicely. Chill, just chill with the factorization. Nice, beautiful factorization. Just factorize so that I can tick that the factorization is also fine. You should notice something with your factorization, and stuff. Yeah, I'm sorry, guys. I think I need to adjust my comments there. Buyi is buoying. Hi, Buyi is making a comeback. Yo, Buyi for president. All right. When you factorize this, remember positive means same signs. Same signs, guys. The positive means same signs according to who? Who governs the signs that we should have inside the bracket? This guy governs. Okay. Guys, remember this only applies when we have positive. Same signs according to who? According to the sign of the middle term. So we're going to have a negative and a negative. Factor of 4. Multiply, you get 4, add, you get negative 2. I get 2 and 2. Then we have x and x. So thank you so much, Buyi. You are a rock star. Aroka wena. Then after factorization, yes katata. After factorization, factored right, we write down the critical values. When we write down the critical value, please guys don't forget, please write down CV. If you don't write down CV, guys, then you are saying to your teacher, this is the final answer. Don't do that. Please write down CV. Your teacher must see you write down CV. I know some teachers say write down the actual word, critical values. Okay, please. We do this only for your inequalities. Please, guys, don't use CV for something else. Just use CV when you are solving inequalities. What is your critical value? What are our critical values in? I'm going to end this live at 9, guys. 9 o'clock, I'm going to end the live, okay? 9 o'clock, I must end the live. Yeah, I must end the live at 9. Yes, Ziwe, thank you so much. Critical value, we write down x is equal to 2. So once again, we have 1 critical value, not 2. You see, so already in our heads, we're like, okay, our parabola is going to be one of those. Hey, it's going to be one of those. Okay, one of those. People are asking me, when is my next live? I have no idea. Katata. Okay, I'm someone who usually goes live either in the morning or in the evening. Usually if I go live in the evening, it's at 9. But guys, I am always not doing the same grade. So, when I go live next time, I might not be doing grade 11. Okay. I do grade 11 next week again or something like that. Next weekend on Saturday, who knows? Okay. Alright, so critical value is 2. And our graph is going to be one of those ones because it only has 1 critical value. If it had 2, it would be one of those ones that cuts in 2 places. But because it has 1 critical value, it's one of those ones that cuts at 1. It's one of those ones. Okay, it's one of those ones. Okay. This guy. This guy. Thank you so much. Thank you so much for the second rose of the day. Really appreciate it. That guy, I appreciate it. Siziwe, thank you. Siziwe. Ngiyabonga. Ngiyaleboga. Okay, so 2. There, guys. Alright. Now, what is it time for? It is time to do what? After graphical representation, we now must interpret. What are we interpreting, guys? We are interpreting the inequality sign at this stage. What does the inequality sign say? Greater than 0. What does that mean? It means where y is positive. Where is y positive? Above x-axis into it. Above the x-axis. Okay. There's no equal sign, so that means our focus now is not on the x-axis. It's only above the x-axis. So now when we check above the x-axis, hey, here we are, boss. Here we are. We are above the x-axis. Okay. We are above the x-axis. Hi guys, we are above the x-axis. Okay. We are above the x-axis. So let me show you the various ways you could write your answer here. You can see that we can either write x is less than 2 or x is greater than 2. This would be an acceptable answer to write. X is less than 2 or x is greater than 2. We did not put the equal sign because we are only looking at above. We are not looking at on the x-axis. We are just simply looking at above. So where x is less than 2 or x is greater than 2, we have an answer. One way of writing the answer. Or you could say x is an element of real numbers. What does x is an element of real numbers means? It means x for every x value left to right, we are sorted. With one exception, x cannot be 2. One way of writing the answer which is acceptable, or you could say x is an element of real numbers. In other words, for every real number, remember real numbers are all the numbers in the number system. Every real number you can imagine, this applies. There's only one exception. X cannot be 2. After 2, every number applies. Before 2, every number applies. But x cannot be 2. So this is one of 2 ways of writing the same answer, just in different ways. There's obviously Mr. Interval notation, which is the third way we could write the answer. Okay, so you don't write all of the, no, you write one of any of the 2 ways. You must decide which one. Or you can write your answer in interval notation. So where are we coming from this side? Negative infinity to who? To 2. But is 2 included? No. So we are going to use open brackets for 2 because 2 is not included. Then we put that union symbol. Okay, this union symbol means or. We could put the word or we could put the symbol, which basically means or. We open brackets to where? To positive infinity, in that direction. You open the brackets. This is interval notation. You could write your answer in this way as well. Okay, so it's up to you. Which way you want to write your answer. All these 3 ways. If you wrote your answer this way, very good, 100%. If you decided to write your answer the second way, 100% correct. If you decided to write your answer in interval notation, 100%. You must decide which way you want to write. First and last. You are saying first and last is you. It's up to you. You must decide. It's up to you. Alright? One way fits the description. And as you can see, and I hope you can see, that all 3 ways work, but you must choose one and then flow with it, my dear. Okay? There's one more scenario for one critical value that I want to look at, and that's when this has L greater than and equal. Let's look at that last situation before I end the slide. When there's one critical value, and okay, so let's do this. Let's make it a bit exciting. You know what I mean? Exciting. Let's make it exciting. Negative x squared plus 4x less than or equal to 4. Let's make it a bit exciting here. So we're given this inequality. So we know that our step number 1 is to make sure that the inequality is in standard form. Is that the case here? Is the equation in standard form? No. So we are going to work towards making sure that it is in standard form. So we keep the negative x squared for now. We take and then we keep the 4x as well. We take the 4 over, becomes negative 4 less than or equal to 0. We are close to standard form. The coefficient of x squared is negative. We can't have that. So what do we do? To achieve standard form in this situation, we are going to divide by a negative 1, that is. So if we divide this by negative 1, this becomes x squared. We divide this term by a negative 1, a positive divided by a negative, is a negative 4x. We divide this by a negative 1, it becomes a positive 4. And remember, we do the same thing on the other side. We divide 0 by negative 1, it stays at 0. Alright. When I divide by a negative, what error did I make here in the first step which I shouldn't have made? I made a deliberate mistake. Tell me, what should I have done which I did not do? X squared minus 4x plus 4 less than or equal to 0. Is this correct? Would this be an acceptable inequality having divided by a negative 1? Bukhang, no ways. This is wrong, guys. Very good. Thank you, Esihle Molomo. Yes, that guy. Okay, we were supposed, this I shouldn't have done. What should have happened? Okay, let me just scratch that out, because guys, when you make an error, please, even in a test or in a classwork, scratch out the entire thing, rewrite. Let's divide by negative x squared. Negative 1. We get positive x squared, divide by negative 1, negative 4x divide by negative 1, positive 4. Then what happens to the inequality sign? It changes direction. It was less than or equal to 0, now it's greater than or equal to 0. We have now officially achieved standard form. Standard form, true standard form, is when the coefficient of x squared is positive 1. Our a is greater than 0, we are safe. Sorry, not positive 1, it's when the a is positive. Sorry guys. Okay, so standard form achieved. Step number 2, what do we need now? After writing the equation, or the inequality in standard form, we now have to factorize. And we factorize, guys, whilst retaining the inequality. So we are going to open two brackets, greater than or equal to 0, and we are going to say same signs plus according to the sign of the middle term, so negative and a negative. Factors of 4 are 2 and 2, and then x squared, x, and x. Then factorization has been done. 3 critical values. Critical values. Now the question is, do we get 1 critical value or do we get 2? Because if we get 1, we know that if there's 1 critical value, then guys, we are safe to say that our graph is going to touch the x-axis once. So there's only 1 critical value. CV is x is equal to 2. Okay, guys, that's 1 value. You don't have to say the critical value is 2 and 2. No, there's only 1 value. Okay, what do you substitute here in x to get 0 in the bracket? You substitute 2. What do you substitute here in this x value to get 0? You substitute 2. This 1 value. To write 2 and 2 doesn't make sense. There's only 1 2. So you just say x is equal to 2. Don't say 2 and 2. Please, guys, make sure to write CV when you write down your critical value. Don't just write your critical value like this. Say x is equal to 2 without writing CV. Okay, that's to show the person who's marking that, no, I am writing down my critical values. Then, after writing down your critical values, graphical representation. So you are going to draw your x-axis. 2 is the critical value. You then draw a parabola that touches the x-axis at 2. And after doing so, what follows next? After doing so, what follows next? After doing so, what follows next? You go and interpret. What are we going to interpret here? We are going to interpret what greater than or equal to 0 actually means. Okay. I don't know what Siziko is saying. So our graph is not negative. Okay, so Siziwe, remember that I have two choices when I draw my graph. Okay, you can draw your graph on the basis of your standard form, the inequality sign having changed, or you can draw your graph on the basis of the standard form before you divide it by a negative. So it's up to you. It's really up to you. Either way, okay, so allow me then to look at when the graph has been drawn after the division of negative, because we are going to interpret, if we are going to use this standard form, we are going to interpret according to this inequality sign. So just allow me to do this, and then I will revert back and look at the other option. Okay, so let's look at this option first. So this has been drawn according to the standard form that I have after dividing by negative. Let me be deliberate in saying that. So when I interpret, I'm interpreting this according to the coefficient of x squared, which was positive. So this means concave up. Okay, so let's be specific, and I hope you understand what I mean. Siziwe. Okay, I hope ngikusiziwe. Okay, so then what we then do, A is positive, right? So I'm going to look at this inequality at that A being positive. So what does it mean? Remember, greater than 0 means y is positive, which means above the x-axis. So let's go and identify that using our graph. Where is above the x-axis? There it is. Okay. Yeah. Okay. Then the equal part, what does it mean? Equal to 0 means on the x-axis. So that means our focus is also going to be on the x-axis. So guys, if that is the case, then we can simply say this: x is an element of all real numbers. X is an element of all real numbers. From left negative infinity to 2, and from 2 to positive infinity, including the 2 as well. That is all the real numbers that will satisfy the interpretation of this quadratic inequality. So that's one way of saying the answer. Or we can say x is less than or equal to 2, or x is greater than or equal to 2, right? Interval notation. Yeah, because there's no answer that will not satisfy. Interval notation would be x is an element of negative infinity all the way to positive infinity. Everything, guys, everything from negative infinity. 2 is also part of the answer because we're looking on the x-axis. 2 is included. So from negative infinity to what? To positive infinity. Okay, so the shortcut, straightforward answers, really and truly, if we are talking about specifics, x is an element of R is very direct and straightforward. X is an element of R means all the real numbers. There's no real number that is not part of the answer in this situation. Or we can say x is an element from negative infinity to positive infinity, there's no answer that does not satisfy the inequality. Okay, so I hope that's clear for us. Now, for Siziwe, if I had decided to use, okay, no, Kadada, I'm doing inequalities because I decided to do inequalities. It was not a topic request. Okay, yeah, term 1. Inequalities are in term 1. All right, so I'm doing them because they tend to be a problem. All right, so I'm just doing it. Then let's look at if Sizi, where we had decided to use this part of the standard form where a is -1, the concave down graph would have worked, right? But it is a concave down graph touching just 2 here. Then if we are going to interpret using that graph, we are not looking at this one, we are looking at less than or equal to 0. Then we ask ourselves, what does less than or equal to 0 mean? The less than part means where y is negative. Where is that? Below your x-axis. Okay, where is below the x-axis? Okay, equal to 0. What does equal to 0 mean? It means on the x-axis. So that means exactly there. What then do we say is the answer? Guys, you can see from left to 2, we are below. Add 2 on the axis, equal to 2. From 2 all the way to infinity, we are still below. The function is below everywhere. It is on the x-axis at 2. So therefore, we can write the answer as x is an element of real numbers. We can write the answer as this, or we can write the answer as that. Hopefully that answers your question. That's if you decide to use the standard form where a is negative, your answer is still the same. I hope ngikusizile siziwe. Vele wena phela usiziwe. Ngiyacela mangilahleka ngisikize. Alright, okay guys, yeah, I think that's pretty much what I'll do for today. Thank you so much for joining the live. I really appreciate it. Hope that this session was helpful. Alright, remember, I did not cover everything that has to do with inequalities. I simply covered aspects that are foundational to inequalities. The part that is important is interpreting, guys, the inequality. So from the first problem, you could see this situation had 2 different critical values. That's why your critical values had a graph that cuts the x-axis at 2 places. We still interpret this and then write our answer accordingly. Okay. 2 critical values that were different. We interpret that. We write our answer. 2 critical values that are different. We interpret this. We write our answer. Now, 1 critical value. The graph does not cut 2 places. It only touches the x-axis once at the critical value. Then you interpret this. You write your answer. You see, please guys, please, you could see less than 0 for 1 critical value, less than or equal to 0 for 1 critical value, greater than 0 for 1 critical value. You saw the situation. And then lastly, 1 critical value for this situation, and we looked at both when the graph is concave up for this inequality sign, interpreting that, and when the standard form has the a value being less than 0, we looked at the interpretation and we saw how that comes about. So all in all, yeah, we did that. So thank you so much. Hopefully that was helpful. And as I said, I will be posting the live video as you see it on my YouTube channel. The link is in my bio for the YouTube channel. You can check out that video. Hopefully I'll be able to post it before 10 a.m. Thank you so much. Have a beautiful and wonderful Saturday day. Take care of yourself. Until we meet again. Ciao, ciao. Ciao, ciao. And let me just also appreciate and thank those that were able to those who contributed to my live goal of roses. I appreciate you, Mr. That Guy, and Sizzy, where I think that was the two of you. So thank you so much. I really appreciate that too. Yeah.